Okay, so we finished last class talking about common Pythagorean triples, and those, like I said before, were a set of three positive integers that work in Pythagorean theorem. So they're nice whole numbers that make Pythagorean theorem work. And some examples of Pythagorean triples are 3, 4, and 5, 5, 12, and 13, 8, 15, and 17, and 7, 24, and 25. So there are two different ways that we can do this problem here. And one of those ways is just the classic Pythagorean theorem. So we could just use Pythagorean theorem like we're used to, where we do the hypotenuse squared, so that would be 24 squared, equals 10 squared plus x squared, and then solve for x. And this is what we were doing on the first page, just using Pythagorean theorem. But the other way that you can do this is using the Pythagorean triples. And if you look at the numbers over here, 10 and 24, and you think about the greatest common factor that they share, which is 2, and you reduce them, reduce the ratio between them, it reduces to 5 and 12. And you'll notice that this Pythagorean triple, 5, 12, and 13, works. So that means this hypotenuse side would be 13. And like we talked about before, the hypotenuse always has to be the longest side. So using this extended ratio of 5 to 12 to 13 on this triangle, and we know that this triangle is twice the size of 5, 12, and 13, that makes the hypotenuse 13 times 2. We just had to double it like we doubled every other number in the ratio. If you had done it using classic Pythagorean theorem, you also would have gotten 26 for x. So there's two different approaches to that. And if you're more into using formulas, Pythagorean theorem, just the classic Pythagorean theorem, would work better for you. But if you're more into doing mental math just based on kind of what you feel is common sense, you can also use Pythagorean triples when it works. It doesn't always work, though. Sometimes you have to use Pythagorean theorem. So as we've talked about before, the hypotenuse always has to be the longest leg. Okay, so if you haven't made a note of that, you should make a note of it. It has to be the longest side of the triangle. So in a Pythagorean triple, in the Pythagorean triples that we were working with before, for example, if you have a 3, 4, 5 triangle, the longest side, 5, absolutely has to be the hypotenuse in a right triangle. These two sides can be either one of the legs because they're the shorter sides. Okay, so this is something to kind of point out, because just because you see these numbers doesn't mean you can use a Pythagorean triple. So this question says, in a right triangle, if the two legs have lengths of 3 and 5, so I'm going to try to draw as well as I can to scale a triangle with sides of 3 and 5. Can the hypotenuse have a length of 4? Here would be the hypotenuse of length 4. Did this form a triangle? You can clearly see that it didn't. The side of length 4 didn't make it that far. But if you had legs of 3 and 4, that would work just fine as a Pythagorean triple. Your last side could be 5. Okay, so the last style of problem I want to do in this section of 7.1 is deciding, if you are told that 3 sides are a Pythagorean triple, what the length of the third side is. Now, you don't know if these two given sides are legs or a leg and a hypotenuse. They don't specifically tell you, they just tell you that they are sides. So you need to set up two problems for these. You need to set up one problem where your unknown side is a leg, and another problem with your unknown side as a hypotenuse. Okay, so let's go ahead and do that. obviously, if this is going to be the hypotenuse in our first problem, I'm going to set up the unknown as a leg. So I'm going to do 45 squared. That has to be the hypotenuse since it's the longer or the bigger number. And my unknown is going to be a leg, and it's going to be x squared. So that's one problem that you have to set up. Okay? Your other problem that you set up then would be your unknown as the hypotenuse. So x squared equals 28 squared plus 45 squared. And you can go ahead and do these on your calculator if you want to, since these are such big numbers. Okay, so on this first problem, you do not get a whole number when you solve for x. I trust that you guys know how to solve for x here. You get 35.23. And when you solve for x on the other problem, you do 28 squared plus 45 squared, and then you square root it, you get 53. So whichever one you get the whole number for tells you what your missing side is. Because again, remember, we want these to be a Pythagorean triple. So there's my missing side. Now, I need to also decide whether it is a leg or a hypotenuse. So let's look at our original equation that we set up. Did we put that unknown side in for the leg? Well, here are the legs. Those are our known sides. So our unknown side was the hypotenuse. So then we also tell our reader, oh, that's the hypotenuse. Alright, so I would like you to pause the video at this time and try and do the next one on your own. Remember, you need to set up the two problems. It doesn't really matter what order you do them in. So go ahead and try and set those up and see if you get the same answer as I do. Okay, so when you solved for the unknown side being the leg, you may not have done that first, but I did it first. You get that your unknown side is 33. So I automatically know that's my missing side because that's the whole number. And it's not a Pythagorean triple if it's not a whole number. So I can say my missing side was a leg, and my whole number that side is 33. When you set up your hypotenuse problem, you would get 85.8, which I know that doesn't work in the Pythagorean triple because that's not a whole number.